Hi, welcome to Practical Electronics Simplified. In this tutorial, you will learn how to generate a square wave using PWM peripheral. So without wasting much of our time, let's get started. Let's understand the basic terminologies of a square wave. In this graph, you can see amplitude, which is 3.3 volts in our case, time period, T on and T off. Duty cycle is defined as the percentage of time the square wave is on over a given time period. Similarly, frequency is defined as the number of waves that pass a fixed point per unit time. Before we jump to Halcogen settings and writing firmware, let's understand the schematics. We will be using EPWM5A pin to generate the square wave output, which will be seen on the oscilloscope. On our launch pad, J2 header, pin 3 corresponds to PWM pin. In the same area, there is a ground pad that will be used as a reference to oscilloscope. Now let's jump to Halcogen settings. Under Driver Enable tab, we enable ETPWM driver. Under PinMux tab, we enable ETPWM. Under ETPWM tab, we enable ETPWM5. Now go to ETPWM5 tab. You can play with these parameters to generate your square wave. For this demo, we will be generating a square wave of time period 1000 nanoseconds with 50% duty cycle. With these settings, we generate the Halcogen files. Now let's jump to Code Composer Studio. You can check out my previous videos on getting started with Halcogen and Code Composer Studio. That being said, we need to include etpwm.h header file. In the main function, we call init and start tb clock function. The while one loop remains empty since the PWM peripheral does the job of generating the square wave without involving the ARM core. With this, we build and run the code on Launchpad. Now the firmware is running on the Launchpad. You can see the square wave on the oscilloscope. I hope you enjoyed this video. Do like, comment, and share this video to support my channel. That's all for now. See you next time.